Welcome to your Daily Dopamine with Dr. Joe McCullough, where we deliver daily doses of education, entertainment, and inspiration. So sit back, relax, and get ready to be dopamine, dopamine, dopamine. Oh, yeah.
All right. Ooh, this is going to be a good episode, Lily. You are correct. Silver lining. Welcome, everybody. Hey, hi from UK, Jason949. All right, hey there. My name is Joe. I'm the physics program chair at Cabrillo College in Santa Cruz, California, and I have a special treat. Hi from Derby. I've already shown you once how to liquefy air. Good evening, Lily. Today, I'm going to show you how to turn air into solid air. So first off, what do I have here? Let me turn this around. So we're dealing with liquid nitrogen. So I just made liquid nitrogen ice cream for about 150 fourth graders. Have some liquid nitrogen left over. So first let me fill up this cup. So what you're seeing here is nitrogen in liquid form. Now, the air that we breathe is about 80% nitrogen. This is nitrogen in liquid form. You can see it's boiling. The reason it's boiling is because liquid nitrogen actually boils at 321 degrees below zero. So this is actually a cup, basically, of air, cup of nitrogen. Does it do toast? And first, what I'm going to show you is how you can liquefy air. So what I have here is a large balloon. What I'm going to do is put the balloon inside the liquid nitrogen. That will cool the air inside this balloon to the point where the air inside the balloon will turn into a liquid. So let me first show you this and then check out, once this is completely deflated, the bottom of the balloon, and I'm going to show you that it's turned into liquid. So I'm putting the balloon inside the liquid nitrogen. You will see the balloon slowly start to collapse. Slowly but slowly. Balloon is shrinking in size. Why is this happening? It's because the air inside is being cooled down to hundreds of degrees below zero. And once I get all the air cooled down, what you'll see is all the air in this balloon has turned into a small amount of liquid. And then I'm going to show you how to turn it into a solid. I'll show you what happens if you touch the nitrogen with your hand in a second. So if you can see that little bit of liquid right there, that is all the air in the balloon that has turned into a liquid. We'll do this one more time. That is dangerous if your skin, if you were to put your hand in and leave it there. So again, what you're seeing here, that little bit of liquid, that's the air in the balloon that has gotten so cold that it's turned into a liquid. No, it's not a condom. It is just a clear balloon. So let me show you this. Kind of cool. You'll see as the balloon heats up, or as the air in the balloon heats up, the balloon starts to inflate. Pretty sweet, huh? Now, in terms of what happens if you were to touch liquid nitrogen. Now, I can put my hand in quickly and bring it out. And the reason I can do that is because liquid nitrogen boils at 321 degrees below zero. My hand is obviously at probably skin temperature, 90 degrees, something like that. As long as I put it in and out, it's fine. But if I were to put it in there and leave it there, then I would not want to do that. It would freeze my hand. So the question is, how can I cool this down even more and actually turn this liquid nitrogen into solid? And the answer is, I don't have an easy way of cooling it down, but what I'm going to do is put some liquid nitrogen. How do we get liquid nitrogen? You can get it at any welding supply store. So what I'm going to do is put some liquid nitrogen inside this container, and then I'm going to put it in a vacuum chamber. And what I have here is a vacuum, and what I'm going to do is pump out a bunch of the air from inside this glass canister. As the pressure drops, the temperature at which liquid nitrogen boils will drop, and I have something called evaporative cooling that happens, and hopefully what you're going to see is this turn into a solid. All right, so I have a bit of liquid nitrogen in there. It's boiling off because it boils at 320 degrees below zero. I'm going to put the cap on. Hopefully you'll be able to see this. I'll zoom in. And then once I turn on the vacuum chamber, hopefully you're going to see that this will eventually solidify. All right, so I'm turning on the vacuum. I'm starting to decrease the pressure inside this glass canister. As the pressure decreases, the temperature of the liquid nitrogen is going to drop, and hopefully you'll see that this will actually turn into a solid. When you see that, that's pretty much just the air in the room that has been solidified, because air is about 80% nitrogen. It's going to take a few seconds. You'll see it's boiling rapidly. Oh, check it out. You can start to see it turn into a solid. Pretty sweet. Would the glass eventually break under pressure if I had a really, really good vacuum? Yes, the vacuum I'm using here is not good enough to cause a big enough pressure difference for the glass to break. All right, so now what you're seeing is the air in the room, this liquid nitrogen, that is now turned solid. You're seeing solid nitrogen. Now if I turn off the vacuum chamber, what you'll see is that this will start to melt. Bam, check that out. Went back from solid nitrogen to liquid nitrogen. Let's do that one more time. I'm going to turn the vacuum chamber back on, and you will see, hopefully, this nitrogen turned to solid again. So again, what I'm showing is, this is just liquid nitrogen. Nitrogen at 321 degrees below zero. I put some of it in a small container. Let me put a little bit more. All right, so now what I'm going to do is pump out some of the air from inside this glass canister. When that happens, the pressure inside is going to drop, and hopefully you'll see this turn solid. So I'm going to turn on the vacuum chamber. Let me zoom out again just to show you what the setup is. I've got a glass jar, a little bit of liquid nitrogen here, and I have a vacuum pump. I'm going to decrease the pressure inside the canister, and you'll see this liquid nitrogen turn into a solid. Here we go. So what you're hearing is the vacuum chamber. It is decreasing the pressure inside the glass canister, which is lowering the temperature of the liquid nitrogen. And if I can lower it enough, you'll see the nitrogen actually turn into a solid. All right, so here we go. Give it about 30 seconds. So why the liquid nitrogen turns solid in low pressure? I'm decreasing the boiling temperature. So instead of boiling at 320 degrees below zero, it boils at a lower temperature. And then something called evaporative cooling happens, which drops the temperature even more. And check it out, it's turning into a solid. A little bit hard to see, but what you're seeing right now is nitrogen in solid form. The container is moving a tiny bit. All right, and then I'm going to stop the vacuum again, and then you'll see it turn back into a liquid. So now, watch closely, you'll see the solid start to turn back into a liquid. And now it's back into liquid nitrogen. Oh yeah. Whoops. Turn it. All right, so that was it for today. Physics is cool. Has the glass ever broke? Not this particular one. It's a pretty thick glass container. For those of you joining, thank you. My name is Joe, and I'm on Periscope every single day sharing daily doses of dopamine through education, entertainment, and inspiration. Today was a little bit of education, a little bit of entertainment. I will be here tomorrow sharing a pretty cool magic trick. Joe, someday can you explain about neurons? Yes, I've done that before, but I'll definitely do a whole series on neurons. Sticking to your goals and doing it every day. Yes, this is day, I think 73. It's kicking my ass a little bit, but made a commitment. I'm going to try and stick to it. All right, Thank you so much for joining me. Have a wonderful Saturday, and I look forward to hopefully catching you again. Take care.